Hello everyone, welcome to my YouTube channel. So today we are going to be talking about types of recursions. Before talking about types of recursions, first I will give you guys an explanation on what is a recursion function. A recursion function is a function that is going to call itself. It has two parts, which is a base case and the recursive case. Base case is the stopping condition that the function recursion is going to stop. Recursive case is the where the function is going to call itself by preparing parameters for next recursive call. Here, this is an example for recursive function. Here in this function name is recursive f. In this, if return result, this is going to be the base case where the function recursion is going to stop. Else part, here you can see return recursive f. This has the same name as this function's name, so this is where the recursive case is going to be called. This is going to prepare parameters and process them for the next recursive call. So next we are going to be talking about types of recursions. So up next is types of recursions. There are two types of recursions, which is direct recursion and indirect recursions. So direct recursion is where the method is going to call itself, whereas in indirect recursion, which is going to be opposite, where the method is not going to call itself, it's going to be called through another function. So in direct recursions, there are 5 types: tail recursion, head recursion, linear recursion, tree recursion, and nested recursion. First, we are going to be talking about tail recursion. Then after completing direct recursion, we are going to be moving into the indirect recursion. So up next is tail recursion. So tail recursion is where the recursive call is the last operation which is going to be executed in that function. This means there's nothing left to do after the function calls itself, and that is the last operation the function does. So in this example, this is a tail recursion implemented using Java. Here you can see this is the recursion function. In this recursion function, name is tailf, which is going to take integer n as parameter, checks whether that number is greater than 0, print that number, sout means system.out.println. Then it is going to call the same function. Here you can see after this recursive call, there are no any operation being done in this function. So this is a tail function. So what this function does, here in the main function I have taken integer 3 as an argument for the function. So it is going to take 3, checks whether 3 greater than 0, yes, print that number 3, then going to call the function itself, subtracting 1 from the integer number we inputted. So 3 minus 1, 2, checks whether 2 greater than 0, yes, print that number, calling the function itself, subtracting 1 from the 2, function 1 greater than 0, print that number also, 1 minus 1, 0, 0 greater than 0, no, that is the base case, then return the result. So the output is going to be 3, then 2, then 1. That is the recursion function, tail recursion function. After this, we are going to be talking about head recursion. So up next is the head recursion. In this, the recursive call is going to be happening at the beginning of the function. So this means before any other operation, the recursive call happens. After that, all the operations are going to be done. So in this example, here you can see class head recursion. the recursion function is going to be headf. Here, this is the recursion function. Here you can see the first statement is the recursive call. After that, all the operations are going to be done. So in order to understand this, we are going to be taking an integer 3 from the main function, and it's going to be used as an argument for this headf function. So going to go to this function integer 3, checks whether 3 is greater than 0. Yes, then it's going to go to the next recursive call, which is headf n minus 1, which is 3 minus 1 2. Then after that, it's going to go to that function again, headf2. 2 is greater than 0. Yes, it's going to call headf1. So in order to understand this, here is the call step, where you can see first it is going to call headf3, then go to headf2, then go to headf1, then go to headf0. So headf0 is going to be the one where it hits the base case. When this hits base case, it starts the process of returning from the recursive call. So first it's base case, then what this does is it's going to go up the stack, performing the operations of the previous call. So this is going to go up the stack, performs the operation of this call. So the operation is going to be sout10, printing the number we have given to that function, which is 1. This is returning 1. Then it's going to go up the stack again, returning 2. Then going to go up the stack again, returning 3. So the output is going to be the first 1, then 2, then 3. First 1, then 2, then 3. But in the previous recursion, which is tail recursion, it was the other way around, 3, 2, 1. That is because in that the recursive call has been done after printing the element, whereas in this recursive call is being done before printing the element. So all the printings are going to be done after it hits the base case, and then it's going to go up the stack by going to the previous call. Then all the values are going to be printed. After that, after that is the linear recursion. So up next is linear recursion. What this linear recursion does is the function is going to call itself only one time each time it runs. So for this, the examples I did in head recursion and tail recursion are also examples for this linear recursion, as they both had only one recursion call inside the function. So here in this example, this is the recursive function. Here you can see there is only one recursive call, no any other recursive calls being done inside this function linear f. So what this function does, first it's going to take integer 3 as an argument, then checks whether integer 3 less than or equals 0. If not, going to print the statement, we're going to print the number here, first 3, then going to call the function itself by subtracting 1 from the number we inputted. 3 minus 1, 2, goes back, checks whether 2 less than or equals 1, no, then print that number 2, gonna go back to the recursive call again, by subtracting 2 minus 1, 1. Checks whether 1 less than or equal 0, no. Print that number again. Going to go linear f, 1 minus 1, 0. 0 less than or equal 1, yes. Fix the base case, simply exit the function. So the output is going to be 3, 2, 1. So the examples I did earlier are also linear recursions because they both had only one recursive call inside the function. So up next is tree recursions. So up next is tree recursions. Tree recursions is where a recursive function is calling more than one time within the time of its operation. So here in this Java code, uh, the recursive function name is treef. Is treef. So what this recursive function does is, first it's going to take parameter integer n as parameter, checks whether that number is less than or equal 0. If it is, then simply return from the function, which is base case. Otherwise, print that number. Then after that, go to the recursive function by subtracting 1 from the number we inputted, and after that again go to the same function again by subtracting 2 from the number we inputted. So here you can see the recursive call has happened 2 times within the recursive function. So this is a tree recursion. So in order to understand the output of this clearly, let's look at the tree structure for this code. So first, taking an integer 3 as an argument for this treef function, checks whether 3 is less than or equal 0, no. Otherwise, print that number, printing 3, then going to go to treef n minus 1, so treef 2. Then going to treef 2, 2 less than or equal 0, no. Print that number. Then going to go to the treef 2 minus 1, treef 1. Then after that, going to print this number because 1 less than or equal 0, no. Printing that one. After that, it's going to go to treef n minus 1, 0. 0 less than or equal 0, return. And after that, treef n minus 2, which is treef minus 1, it is also less than 0, return. So here in this code we have to understand that the second recursive code always happen after the completion of the first recursive code. That's why it has completed the leftmost part first before going to the rightmost part. Here you can see first it's going to print 3, then after that it's going to print 2, then after that before printing any of the values from this side, it's going to print this one. After completing all this leftmost path code, then we are going to go to this rightmost path. So in this, the output is going to be, I'm going to write the output here. First, it's going to print 3, then it's going to go to this leftmost tree side, printing 2, going down the tree branches, printing 1. Here there is no value being returned because this is hitting the base case. Here treef1, printing 1. In these branches also not giving a value because they are in the base case, returning. Then after that we are moving to the rightmost path. Here treef1, printing that one. Then after that 3f0, not this is the base case, and 3f minus 1 also it in the base case, no value being printed. So we have to understand this one is being printed from this 3f function. So first, these functions, all the operations are being completed before moving to this 3f n minus 2 recursive function. Here the output is 3, 2, 1, 1. So up next is nested recursions. So up next is nested recursion. So nested recursion is where a recursive function call itself within its own parameter. So for that, let's look at this Java code as an example. Here in this function nestF, this is the nested recursion function. This is the recursion function. What it does is, it's going to take an integer n as an parameter, checks whether the number is less than or equal 1. If it is, returning 1 as the base case. Otherwise, it's going to return nestF. Then you can see here in this nested recursion, it has called nestF n minus 1, which is calling itself inside this own parameter. So here that is a nested recursion. So in order to understand what this function does, let's look at this call stack type. Here in this main function, I have called the nested function by taking integer 4 as an argument. So here nested 4 is going to take 4, checks whether 4 is less than or equal 1. If it's not, then it's going to return nestF 3. Then that nestF 3 going to check whether 3 is less than or equal 1. No. Then it's going to return nestF 2. Then that nestF 2 also going to check whether 2 is less than or equal 1. No. Then it's going to also return nestF 1. Here in this nestF 1, 1 is less than or equal 1. It's the base case. So here when this nestF 1, when the function goes to nestF 1, it hits the base case. Then this returned value 1 is going to be used as the argument for the outer code. Here you can see the value here we're going to be returning is 1. Here return return 1. Then that return value is going to be used as the argument for the outer code. So this ultimately becomes nestF 1. Then that also is going to hit the base case, since the 1 is less than or equal 1. It also going to return 1. Then that also going to be the outer code argument. Here this also becomes 1. Then that also going to hit the base case. So this also gives this also returns integer 1 here also. Then that also going to return 1 again, since it hits the base case. So ultimately what this function print is the value integer n. So here no matter what integer value I have inputted for this function, whether it is 1000 or 10,000, it ultimately going to hit the base case and going to output the value 1. Here the output is going to be just 1. So why this happen is, this function is going to spiral itself until it hits the base case, and it's going to go up the stack, just printing the value 1. So that is the nested recursion. Then we are going to go to the indirect recursions. Okay, next is indirect recursions. Indirect recursions is where a function is getting called recursively through other functions. Here, unlike direct recursions, the recursion is happening across other functions, not directly through the same function itself. So, a function is indirectly recursive if the function calls another function and that function eventually calls the original function. So, here this is an example for indirect recursion. So, first let's look at function A. So function A is going to be the original function where the recursive call begins. So this recursive indirect recursion is going to be done until the base condition is met. So here first function fun A, which is going to be function A, takes integer n as a parameter, checks whether the number is greater than or greater than 0. If then print the number. Then after that, here you can see it has not called the function itself, it has called another function, which is function B. So it is going to go to the function B by subtracting 1 from the number here we have inputted. So here this is the function here it's being called. So it's going to take the integer n as a parameter. It also checks whether the number is greater than 0. Then after that it's going to print the number. Then here you can see it has called the original function, which is the one the recursive function starter. It has taken the number and it has divided the number by 2 and it has inputted that number to the function name. So in order to understand what this does, here I have taken integer 10 as an argument for function A. So let's look at the structure. Here function A takes an argument as integer 10. Then it's going to check whether number 10 is greater than 0, yes. Then it's going to print that number. After that, it's going to call function B by subtracting 1 from 10. So it's going to be 9. Then function B is going to take 9 as an argument. It's check whether 9 is greater than 0, yes. It's going to print 9. After that, it's going to call function A again by dividing 9 from 2. So by dividing 9 from 2 is 4.5, but since this only takes integers, it's only going to take the integer part of this number. So it is going to be 4. Then function A again takes integer 4 as an argument, checks whether 4 is greater than 0, yes, print that number, printing 4. Then it's going to take, then it's going to call function B again by subtracting 1 from 4. So it's going to be 3. So function B is going to take 3 as an argument. Then it's going to check whether 3 is greater than 0. Then it's going to print the number 3. Then after that, it's going to call function A again by dividing 3 from 2. So by dividing 3 from 2 is 1.5. Only taking the integer part, which is going to be 1. So function A takes 1 as an argument. It's going to check whether 1 is greater than 0, yes. It's going to print that number. After that, it's going to call function B by subtracting 1 from 1. So it is going to be 1 minus 1, which is 0. So function B is going to take 0. Since function checks whether 0 greater than 0, no, then it hits the base case, then the recursive call finally stops. So here the recursive call finally stops. So the output is going to be, I'm going to write the output. First printing 10, then print 9, then print 4, then print 3, then print 1. That is the output of this function, the output of this code. So that is indirect recursions. Alright everyone, that's it for today's video. I hope everyone got an understanding about what are recursion functions mean and what are types of recursions. So if you have any questions or suggestions, please drop them in the comments and don't forget to subscribe, and I will see you in the next video.